Hi everyone, we're going to do a quick video today just to check out a little bit about the close-up or inner mechanics. We're going to look at the circuits of one of these, the Behringer Eurorack modules, and this is the VCO, the dual VCO module number 112. So let's go down to my setup here and I'll show you what we're going to do. Okay, so here's my setup. Now what I've got here is a microscope camera. Now I'm going to sort of show you a couple of different views of this so you can see what's going on. So this is from the top. It's one of these made in China things, 38 megapixel. It's got a HDMI output and a webcam output. And there's a bit of a controls up there. We're not actually using that. We're just going to use the HDMI feed. What it does give us is it gives us a 1080p 60 frames per second video feed on this, and there's a side view of it too, so you can see it from the side. So you can see the camera parts up the top. You can record straight to a TF card. I'm just going to take the HDMI feed from the back here. There's the actual zoom lens on it, and this thing down the bottom is like a little ring LED light. If we turn that on, there's the module down there. We go back to our blown up view or our actual camera feed, and we can just make that go into focus a bit more. There you go. So you can see nice close-up details of the module, and I can move it around, I guess, as we kind of look at it. Now that is a good little sort of indication to sort of give us a look at how this is made and what's built, you know, really small electronics in here, like the surface mount components. Gives us an idea of how well they've been soldered, and it also gives us an idea of the mechanical engineering side of it. So we can look at the solder mask, we can look at the tracks, and even maybe I'll get myself a little pointer here so we can have a look right in close. So you can see there's the tip of my pencil. It's tiny, 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 tiny zoom in there. So probably not even worth chucking a pencil on. All right, now let's go back to a better view. Well, maybe not necessarily a better view, but this is kind of like the full view. You can see my ugly face. And also you can see me playing around with this thing down the bottom here. Now, what we're gonna do is we're gonna look at the whole module, I guess. A better way to do that, we'll take it off there for a minute. I'll just hold it here. You can see there's the whole module there. Okay, so we're gonna go across all of that, and this is really just for you guys to have a bit of a close-up look if you don't have the gear. One thing I'll mention before I do get into the close-up view is these are the trim pots, the famous trim pots that we've been talking about to tune the oscillators. And there's two trim pots for each VCO circuit. One will be like a pitch frequency, and the other one would be like an waveform width. So you will actually have to muck around with both of those. I haven't touched mine yet. But anyway, let's get into our close-up view, which is somewhere around here. Bang. And what do we start with? Having a close-up look at the trim pots. I just need to focus on it because it's manually focusing. So there you go, there's the trim pot. And we can just move this to the left and you'll see the different trim pots here. And there should be one more. Which way was it? That way. There it is there. All right, there's your trim pots. Okay, now let's have a look at the circuit a little bit closer. Let's get it into focus. Sorry about the manual focusing. It does take me a little while to get it. Now, have I got little hairs on this? There's a little hair there, is there? Yeah. So we just need to... It's picking up everything. Just tiny little hairs. That hair was actually minuscule. All right, let's keep going. Okay, so we're going to start from, I guess we'll start from the top corner here. Give you an idea of how good the soldering is. You can see there's a little bit messy soldering there. And you can also check to see if there's any sort of dry solder joints on this stuff. Go all the way across to the right and to the edge of the PCB. And it's such a close-up view of this PCB that you can see even with the machine cutting the edge of that PCB, it looks jagged. So there you go. All right, let's go past the trim pot and we'll start looking at some of the components here. And we've got our first IC. It's the 4580 8J4E. All right, so that's an RC 4580. It's an op amp, a dual audio operational amplifier. And what it features is low noise voltage, good total harmonic, very, very low total harmonic distortion, and it is a drop-in replacement for the NJM 4580, the famous one. Pin function is compatible with an LM833 as well, which is handy. So this is a dual op amp that has been designed optimally for any audio application, such as improving tone control. It offers low noise, high gain bandwidth, low harmonic distortion, audio output current, a high audio output current, I should say, and all of which makes the device ideally suited for analog audio electronics, such as preamps, filters, anything like that, which is exactly what this is built for. So they've chosen a nice op amp here, a little bit more focused for you there, and out of focus so we can see the other parts of the circuits. All right, so we're heading this way, aren't we? Heading across. We should see another little IC just here, and there's another op amp to the edge. We're just going to keep going this way, and these should be some larger. Here we go here. So what do we got here? We've got an 072C. This is a JFET input, low noise JFET input operational amplifier. Incorporated well-matched high voltage JFET and bipolar transistors. It's a monolithic integrated circuit. The device features high slew rates, low input bias and offset currents, and a low offset voltage temperature coefficient. The low harmonic distortion and low noise makes this ideally suited for high fidelity audio preamp applications. So this is another amplifier type module. Okay, now we've got the big one. This is the biggest chip that I can see on this, and just see if we can get a better view. So this is an LM30. Sometimes you have to tilt it to get a better. LM3046, is that with an M after it? That's what I'm getting there. The LM3, this is a transistor array, and it features 5 general purpose silicon NPN transistors and a common monolithic substrate. 2 of the transistors are internally connected to form a differential connecting pair. So there you go. This would actually be really good for low powered systems all the way up to the VHF range. They are used in the discrete transistors, conventional circuits. However, they also provide a very significant inherent integrated circuit advantage: close electrical and thermal matching. So there you go. It has your transistor circuits on this, because they're dual inline, makes it for very, very handy applications providing signal processing. So that's perfect for an oscillator. And just below that, we keep going that way, you've got your diodes and resistors and capacitors, and there's another op amp there. I think there's another op amp there, and they're just everywhere, these op amps. Lots of 4580s. There's another chip over this way, a bit, another 4580 right down the bottom here. What's this one? Another 072C. So there we go. Another 072C. So there's really only what three different types of chips on here. Makes this very, very simple design. And you can also see quite simply the way this is built. So it's all surface mount components. Now, that doesn't mean it's a bad thing. It just means that that's the way of the future, I guess. So yeah, hope you enjoyed a close-up view. If you ever wanted to know what they look like, let's turn it over anyway, and let's see what it's looked like from a microscopic view from the top. All right, let's have a look at this. Is the 3-position switch. So you can see here, complete with a little hair. Because you can't even see that hair there. Can't even see that. And I don't even know if that's a hair or a scratch. No, it's a hair. Wow. There we go. All right. This is your oscillator waveform selector switch. And you can just sort of get a different view of it. There. Okay. What else can we look at? We'll look at the potentiometers. So, on the top. Ah, look at that. You'd never ever see all that sort of detail. All the way down to the PCB, not to the PCB, to the panel. You can even see the silk screen, the paint imperfections. Let's have a look at one of the 3.5mm sockets. These are always interesting. So nice and focused there. That's the top of it. And we can zoom right in. No, that's right out. Sorry, I go the other way. And we can go inside. So this is the inside. So right down the bottom. So you can see the mechanics right down to the bottom of that socket there. All the way back up to the top. And we can also tilt it. Tilting it's good because you can have a look at the side of it. It's always interesting. There you go. And you can also see just around the edge of that, you can see how it's not, you can see the cut hole in the panel and how that thing there is just kind of not attached to it anyway. It's just floating. So that's also very interesting to look at. We had the switch. Probably a bit too zoomed in for the switch. Complete with the little hairs on it. Wow, crazy. And you can't see them. They're just little bits of dust. You just can't see that stuff. Clean your gear, Rands. Well, I thought I did. Look at the silk screening here. Very interesting. More hairs. So yeah, I just thought I don't know. Look, this camera thing is really just me using it for soldering, but I just thought, wow, let's have a look at some surface mount componentries whilst we're at it. Now, we could look at the side of this, couldn't we? Another thing we're going to do is we're going to look at the mechanical side, and a lot of people are worried about these Behringer modules and how these 3.5mm sockets, they're not actually fixed to that top panel. When you plug something in, you're wiggling it about. We're going to actually look at it at a microscopic level and see what happens when we wiggle these cables and see what sort of stress is on that circuit board and see kind of the mechanics of the electronics and see whether that will stand up. So let's go check that out now. That's the side of the PCB, and that's the side of, there's these are two of the 3.5mm sockets here. So you can see there's the actual socket there. And that goes all the way. So that's where you plug something into at the top of the board, and that's the actual. So what's interesting to note about this is what we're looking at is, we're looking at it what you're plugging something into, but we're looking at it from side on. So this is this here is the front panel, the gray front panel that you can see. This is the socket that you're going to plug your 3.5mm whatever into, right? And you can see how that just floats in the breeze. Let's see how much this thing, is this the right one? This is the one here, okay. So there's the little 3.5mm Eurorack patch cable I'm going to chuck in it, and I'm going to put it inside. Try not to move it too much. All right, so it didn't really move that much. Really hard for me to not knock this as I'm... All right, now if I actually put a little bit... Okay, so let's go over here. There's the cable. Now you can see if I wiggle the cable, see how the front panel does not move at all, but that whole socket is moving. So that's just a very, very tiny little bit of a touch. I'm only just touching that slightly, and you can see that moving, and that moves all the way through. Can you see it move there? So the whole thing is kind of flexing off that PCB. So there's your mechanics of that socket. Now that socket is taking all of the flex. It's kind of, isn't it? It's kind of pivoting a little bit on that bottom part of the board. And I guess the good news here is that we're not seeing that metal shaft move. So that looks like there's a fair bit of mechanics in that. So it looks like there's kind of like a base platform and then this plastic shaft is taking some sort of wiggle movement, absorbing. So maybe there is a bit of mechanics in that. So what I might do is, just on the flip side, I think what we'll do is we'll grab another module that actually has the nut on the top that's mounted to the faceplate of the Eurorack module, and we'll just compare it to see how different that is and just see the mechanics of that. So in contrast, I think what we'll do now is we'll check out a similarly priced module, which is by Dreadbox, and this is one of their chromatic series. Now you'll notice on here that they're 3.5mm sockets. They've got the nut on them. Okay, so what we can do is we'll grab one of these and we can look at it from the side, and let's go to our view here. Okay, so you can actually see the whole socket, the barrel, you can see the nut, and you can see it and the PCB where it's just mounted on. So if we're going to plug this pink Eurorack cable into it. Try not to move anything. Okay. Right, I'm going to plug it in. It's really hard to not move stuff, but right, now if I wiggle, you can see that pink cable's wiggling, right? Try not to move. Try and stabilize what I'm doing with my hands here. Okay, now I'm moving that cable and nothing is moving. That socket is staying still, and the actual whole 3.5mm barrel assembly and the PCB is staying still. It's not moving at all. Okay, so why did I show the Dreadbox module? Well, I guess the argument is that Behringer, they didn't put the nuts on, well, they didn't use the 3.5mm connectors because maybe it saved a few cents or it just kept the prices down. But that argument's out the window because these are actually very cheap priced modules. Not saying they're cheap quality, they're cheap priced. So the price argument is not there. But I'll be a betting man, and I reckon that module will last longer at the electronic mechanics level. Okay. So was that a good decision by Behringer not to put the nuts on? Probably not. But in contrast, why don't we compare its actual competitor, the Behringer competitor, the actual same module? Okay, so the Behringer is the 112, and the competitor to it is the Roland 512. So let's check that one out. And this is it. This is the Roland made by Meleco, the 512. It's exactly the same module as the Behringer. In terms of, oops, upside down, all the electrons are going to fall out. That's exactly the same module in terms of, you know, what it's based on, the System-100m. So let's check out this one. Now, one thing to note is that this module has the nuts around the edge. So you'll see these are the 3.5mm jacks there. They've got the nuts around the edge. Let's have a closer look mechanically at this. Here we go, get it in focus for you. So you can see there's another argument, and that is that these nuts that are on the Dreadbox modules take up too much room, and they wouldn't have been able to fit them in because there's not enough space in the design between the, I don't agree with that, but between those spots there's not enough space. Well, have a look at the way the Roland ones designed them, and they've got these kind of interesting, these nuts, they're quite interesting how they've got the little you know, flathead screwdriver sort of insert on it. All right, so why don't we check out, we've got one on the side here. It's beautiful, isn't it? This camera is really nice. For a cheap Chinese invention, I am very impressed with this. What's nice about this is you can actually see the pink cable here, right? And you can also see the nut. You can see the whole mechanical 3.5mm shaft here. You can see the PCB here, and you can see the soldering spot just here. Right, so what did we do last time? We wiggled the cable. Now I'm going to try not to wiggle anything else. I'm just wiggling the cable. This is actually a good view because you can see the cable wiggle. You can actually see the shaft of the 3.5mm plug inside wiggling about. But that whole PCB, the socket, the nut, and the solder point is not moving at all. So there is my point, and I think I've made it pretty clear. But there's my point. When you're making these products, and they're going to be plugged and unplugged and unplugged and plugged and plugged and you know what I mean, 1,000 times and maybe more in their product life. That part of it has to be superior in terms of build mechanics. That's got to be able to withstand wiggles and plugs and unplugs. It's got to be able to stand, you know, the flex of someone pulling up at it and pushing on it. So all of that has to be part of your mechanical design when you're building these Eurorack modules. And I can tell you that this is made like so much better. This thing is rock solid. It's very, very well made. The Dreadbox one is rock solid as well. In fact, you can actually see the thickness of the PCBs is the same throughout all three of these. But you can see here you've got these, you know, these kind of spaces, and they're nice, strong hex nut, like you see in PCs. Those hex nut spaces, right? Just there. And the whole mechanical part of this is strong. You can feel it. It feels strong. I'm not saying the mechanical part of the board and the design of this doesn't feel strong, because that actually does. It feels quite strong. That's quite well held together. But, right, the only thing that's actually holding this board together, I can look at where the screws are. So inside here, there's a few screws that are holding this onto that PCB, the faceplate. That's holding it all together. But your weakest point is this, and that whole socket thing is just flapping around in the breeze when you're unplugging and plugging, and that's going to cause this to be a fail in the future. But only the future will tell us. So let's come back to this video in 5 years' time, and let's see how well these stand up. And hey, if they're still around and they still work, that's fine. Just remember too, there's different cables, and different cables have different, you know, even the actual plugs on these. I'll give you an example, actually. This is really good because we've got the Microscope Camera here. They're all reputable brand cables, these are. But can you see how the tips of these are slightly different? See how they're all slightly different? So you're going to have, that point is what I'm trying to make, is you're gonna have an issue when you're plugging different cables in, different brand cables. And because some of these will go in snug, some of these will click in and you'll feel it click. Some of these will just kind of feel like they're sliding in and sliding out easily. It all depends on the brand of cable you've got. And that will also make a case for that whole mechanical side of it. And look, I know I'm harping on the 3.5mm socket point, but that is going to be probably the most aggressive mechanical part that your Eurorack module is going to experience. And don't forget, Behringer made that quad gate multiples mults panel, and that thing's got 6x4 24 plus another 16, so that's got 40 3.5mm sockets in that. That is 40 points of failure. So I would definitely have said put some nuts around the edge of that, nuts like like what Dreadbox did on this, little nuts just to hold it. And that's just one more extra part that you can feel comfortable with when you are looking at the build quality. Now, you guys might comment now and say, but Behringer, they're cheap. Well, I thought we've just solved that by, well, the Dreadbox ones are cheap as well. That is not an excuse. To make something cheap priced is not an excuse. To make something, to say, okay, well, we're going to make this cheap. Behringer nowhere have said we're going to make this cheap, therefore, expect our build quality to be crap. They've never said that. I'm not saying their build quality is crap either, because I've actually said they've used quality parts, and we've looked microscopically at the circuit board. It looks to be quite well made. But what I am saying is the design choice for the mechanical side with that 3.5mm may have been a furph, and next time they might need to look at that a bit more seriously. So their semi-modular stuff also has the same problem. So these, even in the Neutron, you've still got these sockets flapping around in the breeze. They're not attached to the panel here. So it's not just those Eurorack modules, okay? Technically, this is a Eurorack module, but yeah. Anyway, that was just a look. This has nothing to do with music. This is just a bit of fun looking at playing around with my new camera here, having some fun, looking at the modules, just getting an idea of how these things are built. You know, you've got the Roland, you've got the Behringer, they're competing, and the Dreadbox there. It was just a bit of fun just to have a look, and I hope you enjoyed it. So please give us a thumbs up and a like, and I'll do more of these. Don't forget to visit me on Patreon. Patreon's a way that I can support running this channel in the future. And if you can't do that, the least you could do is subscribe and give us a thumbs up. That always works. Because I know we're all struggling at the moment. Stay safe out there, and see you in the next video. Catch you later.